Number 11a. Hey guys, what did you give for number 11? But we were given a PDF, right? Given the PDF, find the expected value. Guys, even though this problem isn't stated, it could definitely be a type of problem. If they ask us whether this fx is a valid PDF, what should we do? Guys, we need to check if this f is a PDF, right? We have to see if its area equals 1. Is it a PDF? We need to check if the area equals 1. What do we need to do second? We need to integrate fx from 0 to 2, which means we have pi times the square root of 16 minus x squared, and we need to show that the total integral equals 1. And what do we need to do second? We need to show the total integral of 6x equals 1. What do we need to do second? If the integral value is 1, can we say that it is definitely a PDF? For example, look at this. So we have fx like this. If it's from 1 to 3, here, if the area is 1.5 and this is 0.5 and you approach it like this, what comes out is 1. But is this a PDF? No, that's not right. Why? If it's below the x-axis, when we calculate the probability from the PDF using definite integration, the value will come out negative if it's below the x-axis. But probability can't be negative, right? So we have to check both conditions. We need to confirm that f is greater than or equal to 0. That's right. We need to check that too. We need to show these two things at the same time. If they say show data to us. So, if we're doing this from 0 to 2, shouldn't we first make this 1 for the arc? So did we take 16 out as well? Did we do it right away? Hey guys, since it's in the form of a squared minus x squared, if you can't think of it, you can substitute x with a synth to solve it. Can we do this in any way? You can also do it by creating the form of an arc sign. Right. What's the form of the arc sign? 16. We know that arc sign is 1 minus something squared, right? So, how do we make it 1? Factor out 16. 1 minus x squared over 16 like this. Can we take 16 out as well? Out of the square root. So are we taking it out to 4? So should we make it 4p in the square root? If we say 1 minus x squared over 16 is the same as x squared over 4, then that's how we set up the equation, right? So this becomes an integral right away. With what? Multiply arc sign by x over 4 times 4. Is this correct? What's going on? 6 over 4p. If we integrate this, it becomes 4 times, let's put 2, and 0 into arc sign of x over 4 and subtract them. Is this right, guys? Is the integration okay here? If you integrate, the 4 cancels out and you get arc sign. We're subtracting arc sign 0 or equal 0 from arc sign 1 to 2 over p6 times p6 or 1. The total integral value is 1. In this problem, is this okay, guys? You could definitely ask about this problem, but since no one did, I asked. So what about how do we do the integration next problem? Are we supposed to find the expected value? Then, if we are asked to find the expected value of x within the given range from 0 to 2, we can integrate the product of x and x. Hey guys, when you multiply x and fx, it looks like this. How do we integrate this expression? We're substituting, right? Who are we substituting? You can substitute the expression under the square root, which is 16 minus x squared. We substitute 16 squared, right? When we substitute 16 minus x squared, we end up with 1 over 2x, and that cancels out with this, right? Is this okay, guys? Maybe they did it like this. But maybe some people would substitute x with 4 sin theta when they see 16 minus x squared. That works too. It's fine to do it this way, or just like that. So, after integrating, find expected value. B is a different problem, right? So they're asking to find the probability of being less than 0.5. So what do? We just integrate, right? The probability value is found through integration. And since this problem starts from 0, guys, when they ask for the probability of being less than 0.5, it's not from negative infinity to 0.5. The range of x is defined, right? So the probability of being less than 0.5 is actually the probability from 0 to 0.5, right? Right. So we just need to integrate this from 0 to 0.5. So we just need to integrate, right? And that's how we can calculate the probability. A and B are basic problems, right? Is everything okay up to the basic PDF problems? For B, did you just use that and integrate fx from 0 to 0.5? I think we just need to write down what that value is. Let's keep going. The problem below, up until now, we didn't know what fx was, right? The problem below mentions it. What does it say fx is? In a certain laboratory, 2 millimeter, what reagent? We're doing something with it, but the amount of the reagent, it follows that model. I don't really know what it is, but the amount of that reagent follows this PDF. That's right. Up to 2 minutes from 0 to 2 me. This is some kind of seed. It's about seeds, guys. I looked it up and it's a seed. It seems like we're doing some experiments with something. Each experiment is dependent. We did something, and after reacting it, if that amount ends up being less than 0.5, then it's considered a success. So what we calculated in B was the probability of success, or the probability related to fx. When we calculate the probability up to 0.5, we get 0.239, guys. So what we calculated in B was the probability of success, right? So the probability we calculated for fx up to 0.5 comes out to be 0.239, guys. This fx is actually a model for the amount of this reagent, and in this experiment, we define anything less than 0.5 as a success, right? So we calculated the probability of success. We're repeating the experiment multiple times. This fx was actually a model for the amount of this reagent, and in this experiment, we defined success as something less than 0.5, and we calculated the probability of success, right? We're repeating the experiment several times. How many times do we need to conduct the experiment? Have at least a 99% probability of success. Is okay. We're doing the experiment multiple times. How many times should I try this? Will the probability of having at least one success be over 99%? It's like this kind of question. So I tried to solve this problem, but I'm confused. I'm confused too, guys. There is a chance of success at least once. It has to be greater than or equal to 0.99, right? So to find the probability of at least one success, we subtract the probability of failing all the time. Right? We can't directly calculate the probability of having at least one success. We can't go through each case like having one success, two successes, and so on, right? When we get the L list, we calculate the probability in reverse. So from the total, we subtract the probability of failing completely from the total probability of 1. So we're calculating the probability of having at least one success this way. Then how do we find the probability of failing completely? If we've tried n times and failed every time, what's the probability of failing in a single attempt? Subtract 1 from 10. 0.761 is the failure probability in experiments, failing every time. So when we conduct an experiment once, that's the probability of failing, right? Then probability of failing all n experiments is 0.761 raised to the power of n, isn't it? If we subtract this from 1, isn't that the probability of having at least one success in n trials? So we set up the equation like this. It's greater than or equal to 0.99. Understand this? It means that if we've conducted an experiment, the probability of having at least one success is over 99%, right? So the probability of having at least one success is found by subtracting the probability of failing completely from 1. What does it mean? That the probability of failing completely is 0.761 raised to the power of n. If we've tried n times, we set up the equation that the probability of having at least one success is greater than or equal to 0.95, and then we find the value of n. First of all, this is a situation that has come up multiple times, but in a different form, right? This is a problem we've seen before, like in the past. Is this okay? What's below that, guys? I tried it 10 times. They said they did this experiment 10 times. What happens when you do it 10 times? Calculate the probability of exactly 3 successes. So what do we need to do here, guys? Did you repeat it 10 times? Are all 10 experiments independent? Is the success probability fixed? What we're interested in is the number of successes, right? What's the probability of 3 successes? You guys need to think about the binomial distribution. Is that right? You don't necessarily have to write binomial, but it's fine if you do. The probability of getting 3 successes out of 10 is 0.239, and then you can also do it like this. 3 to the power of 0.761 to the power of 7. That's okay too. You can create a new random variable and then make a binomial distribution from that. It's okay to do this. 3 power, 0.761 to the 7th power. You can create a new random variable and then form a binomial distribution, and after that, it's fine to calculate the probability of x being 3 using the binomial PDF when solving for D. Is this right, guys? Is this okay? What did you ask about 2? How many cases are there of 1 consecutive success? For example, when conducting 10 experiments, you could succeed on the first, second, and third attempts, or on the second, third, and fourth attempts. So you're asking how many cases there are in total, right? You can count based on the endpoints. Guys, what you can do is count from 1 to 8, so that's 8 up to 8. So we just subtract 2, right? When there are 10, there are 8 cases, right? What if there are 11? I think there are 9 cases. Count from 1, 2, 3, 2, 3, 4, up to 90 and 11. If you only count the ones at the very front, you can just count from 1 to 9. Why did we do this? So when you ask how many there are when you do n attempts, did you ask? And then, so when you do n trials, how many cases are there of succeeding? 3 times in a row. 1, 2, 3. It should be around 234 from 1. When you have up to n like this, if you count based on the front, like n1, n2, 123, 234, you could think that there are n2 cases. When there are 10, there were 8 cases, so we subtracted 2. Since there are n cases, there should be up to n2. What are we saying here? Is this right, guys? So when there were 10, there were 8 cases, so we subtracted 2. Since there are n cases, there should be up to n2. What does that mean? Is this right, guys? First, we succeeded 3 times. By the way, guys, this is conditional probability, right? Is it conditional probability? So out of attempts, we succeeded 3 times, right? Right. We succeeded 3 times, and we're calculating the probability that all 3 successes are consecutive, right? Right, guys. Right? How calc this? Hey guys, if we write the formula correctly, does it look like this? Is this conditional probability? What did you say? So, among the cases where we succeeded 3 times, there are a total of n trials from the first one, and first 3, we're trying to find the case where all 3 selected are consecutive, right? So this is conditional probability. But then what goes in the denominator? In the denominator, there should be the probability of succeeding 3 times out of 10. So how do we do that? It's n choose 3. So we need to find the probability of succeeding 3 times out of 10. So how do we do that? N choose 3? Let's just call the success rate p. We calculated it above, but it's p cubed times 1p to the power of n3. So the probability of the case where all 3 are consecutive, guys, will be the same. But there were cases up to n2, right? So here we have n2 times p cubed times 1p to the power of n3. So this is greater than 0.05, right? So is that how we solve this? Since it's going to be erased anyway, this is the only thing left. And we're saying it's greater than 0.05. That's how we calculate it. The Markov chain that's coming out here is actually something that's been omitted, the part that's behind it. What goes in the numerator here is, it's the probability of succeeding 3 times in a row. Is that right? The probability of succeeding 3 times in a row. So it's like this. For example, we have trials 1, 2, 3, and all the way to the nth trial. So the 3 consecutive successes can look like this. Look, if we have 1, 2, 3, 4, and so on up to n, we can have success, 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 and the rest are all failures. So what's the probability of this? This probability is p cubed times 1p to the power of n3. There can be cases like this or failure. Success, 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 failure, and so on. It could look like that. This probability should be the same, right? Multiply probabilities. It must exceed 0.05. Each of these probabilities is the same, and there are n2 of them, right? So we multiply them together. This is the probability of succeeding 3 times in a row when we've done n trials. So this probability is what we're trying to calculate. and it should be greater than 0.05. In the end, since it simplifies, we only need to calculate this part. Anyway, to solve it accurately, you do it like this.